pressure over. So it's in the groups here, but they already have. I'm not the one on 6 months in Thailand. So you just have to get like enough people here to be like, okay, we'll do an extension. Yeah, Association, American Society. It's just like they're thinking of 19, 21 years. I don't know how to explain that. Do that in the I don't know how to do that in the Oh. Sure. Yeah. I'm going software. You need enough people to say, hey, I'm interested. So that you'll start getting low. You don't know what my list to find. If I can focus if you want to do it. But you do you know the interview effect on the full interview? I'll just put on a choice. Oh, that's fine. There's 3 locations possible. Tennessee, Washington State. Let's see how the listing goes after. Let's see. Yeah, the matrix instead of the one we had before. It's not great. Oh, this is one. We tried, but okay. But you're just doing recording, right? I'm just assuming. Huh? This has nothing to do with it. No, it's just assuming. Can you put the number in? Meeting ID. Put that number in. 462. 378. 378. No.
All right. Hello, everyone. Welcome to the Houston Engineering Center Machine Learning Club General Meeting 3. My name is Charles, and I'm here to introduce you to Dr. Robinson. Dr. Robinson is a professor here at UC Tyler, and he specializes in machine learning research in several divisional areas. And without further ado, I'd like to introduce Dr. Robinson.
It's great to be here. Most of you, just from a casual glance, I have the misfortune of having a work class, but we're doing great. So what we're going to do is have what I consider the beginning of conversation for a deep dive into machine learning, and that is really trying to exploit the workforce of machine learning these days, and that's introduction to the Python language. I will go through a few coding examples live. Hopefully, you'll get an opportunity to see me make a lot of mistakes. Don't laugh, because you will make a lot of mistakes too if you take this thing seriously. And we'll work through these things together. just talk about some of the basics of the language, but I do want to stress that this is only the beginning of the conversation. It's the bare rudiments. It's up to you, you know, with the help of perhaps me and more of your resources to make it really what you want to make it. And that's a real emphasis on it. Now, before I begin, how many of you would consider yourselves just absolutely rank amateurs in Python? How many consider themselves very strong? So those that are very strong, now there's a project waiting, especially at this point. So let's go ahead and get started. I want to dive right in, start the coding right away. But before I do, there is an underground mushroom in Oregon that measures 3.5 miles across. Do you believe it? 3.5 miles across. I don't believe it. This bears further research.
Roots is almost the word, but it's not quite right. I can't remember the.
So what I'm going to do is I'm going to bring up a Jupyter notebook that I created. You're welcome to have that. Not worth a lot of value, but it has some notes in there. And it does allow us to have a little bit of interaction. So let's get this started. I'm on my home machine. I'm trying to hack in unless you authorize. Okay, that came up. We're off the running there. Oh, feel free to stop if you have any questions. This is not that type of thing where I drone on and on and on and you get lost and lost and more lost. Okay, so welcome to this live program. Let's talk about some of the basics of Python. Okay, so I will start off by just saying that Python is a language that takes some of the very best features of both C++, C++. I don't distinguish between those very much, and MATLAB. You know, a lot of things are much easier to code than MATLAB, but you know, you kind of compromise a lot of the power that it has. And C++ is one of the most powerful type of languages that you can use on a computer, but the learning curve is a little bit difficult and people don't know it nearly as well as they purport to. But anyway, so Python is a neat compromise for that situation. And so we're just going to kind of dive right into the Python. You'll notice a lot of the constructs are just very similar to what you've seen in other languages. Okay, so in this first cell here, we do simple assignments, and that's what you would expect. We assign two variables, A to 5, B to 7. Both of those are integers, and we printing out A plus B. Then I take that result and I subtract 7.3 from A, and should that be a positive or a negative number? Probably negative, right? 7.3 is greater than. Yes, sir. You have a question?
Zoom in.
Zoom.
Yeah, that's the bare it's on the. Oh, it's on the link. Never mind.
Okay, so that should be negative, and then we just add the numbers again, and then we show the divisions of division and multiplication, and that's it. So we run this. It's just kind of what you would expect. Not that big of a deal. Any questions on that cell? Okay, all right, no, yes. So one thing I know, you may notice my print statements. My print statements don't have parens, they're not enclosed in there. This is because I'm using Python 2. Python 3 includes that. very minor point, nothing really to even sweat about. But the key point behind that cell is it's just as you would expect. Simple assignments, simple arithmetic operation, print out to the user, bada boom, bada boom. Okay. So a key element in any programming language is data structures. You have seen that maybe from C++. You have arrays. I mean, you have just the basic number types, the integers, double precision numbers, all of that type of stuff. Those are just the basic things that make the language work. But Python is a little bit richer as far as those type of structures go. And so we just need to kind of study those fundamentals, because they is what everything runs off of are these particular data structures that we're going to talk about for the next class. So the first one of these are called lists. So lists are a heterogeneous container. They can contain numbers, they can contain strings, they can contain other lists, they can contain dictionaries, tuples, any type of container that Python has can be put into a list. Just anything. It's literally the kitchen sink, and everything goes with that. So here I assign a variable. Remember, we just did that in the previous cell, A. And I throw in 0, and I throw in Melvin, and I throw in a floating point, and I throw in a sentence, and I throw in another list, and I throw in 2 integers that are part of another list, right? It contains everything. And we will see right now if that actually works, if I don't get any syntax errors. So I didn't get any errors in that word. Yes, sir.
Since we're using sentences, did we have to declare a string?
No, there's no type of declarations that go on in the Python language. It's not what's called strongly type. So you just pull it up and use it. No, you don't have to.
There's no preprocessor directly.
No,
okay.
No, nothing like that. Okay. Just assign it and use it right there. That's kind of the good part about it. And part of that is because it's not strongly typed, but part of it is because it's it's not compiled either. It's interpreted. So everything's kind of happening on the fly. So I go in and kind of explain a little bit more, more about data structures. I guess an exception to this, like most languages require heterogeneous structures, meaning that if you start off with integers, all of the elements of that container need to be integers, or else there's going to be real logical problems in that. That's not the type of project for Python. I think I illustrated that. The exception to this would be in C and C++ structs, right? So, and that's a lot more complicated than the list that we just did. Structs can contain heterogeneous type of data too, but this is just a lot easier. So here is so in this cell, I declare another list with another sentence and another floating point number. And I'm going to go and try to add A and B up. So what do you think is going to happen? Can it perform a numerical addition? Can you add, say, pizza and cocktail? Can you add those two up numerically? No. So you would expect it to append, right? That's the operation I expect. But the only way you know is to go into C. So boom. So you see that now you have one big list, and it just simply appended one list to the other. The plus in a list operation, is concatenation. It's not numerical addition. That's a very important distinction. So, what I want to do now, since I have operator, I want to see if I can do something illegal, right? So if you can add elements in a list, can you subtract elements in a list? Can you subtract 2 lists? I don't really know, right? can you multiply lists together? I don't really know that either. But whatever it is, if I go and I try it, the computer's not going to go and take a great big mallet and hit me in the head, right? So it's okay. It's okay to try. I mean, nothing bad is going to happen to you unless you get your feelings hurt from getting syntax errors. And if you do enough development, getting your feelings hurt for syntax error goes away very, very, very quickly. So, okay. So let's do this. Okay. And lo and behold, I got a syntax error. I did do something illegal. The sky didn't fall, right?
Well, this kind of rating.
Well, these are illegal operations, but okay. I know not to try to multiply or subtract lists ever again. So okay. So we move right on. Life is too short to worry about that. Okay. So in this one, so I want to talk about now. So you have a list. Yay, length, long, or something like that. How do I really address individual elements with that list? Right? You know, maybe the whole list is not really not really that interesting, but I just need this little piece. Okay, so I'm doing that here. I define the list. C is A plus B, and then I go through and I extract individual elements out of that. Important to note here is that Python starts its indices at 0, very much like C. MATLAB, Fortran start at 1. Right? So I have a C of 0. The extraction operator in Python is, again, the bracket. So you put the variable, then a bracket, and then which particular element that you want. And that is denoted by what's called an index. So here I want indices 0, 1, -1, and then just for grins, I want to just print out the length of what that list is. Okay. Then I go through and I have another operation, the append operation. I want to add, I have a list, I just want to add some extra stuff to it. So I append a 2 to it, I append another sentence to it, anything goes.
How would you read the address locator? How would that -1 threw me on the whole address?
Yeah, right. So that's why I put that in there. I wanted to intrigue you and challenge you. Right. I'll talk about that in just a second. Okay. So here is let's see. So the print statement. So the first element of this list is 0. Actually, let me print this list out here. Let's see. So the first element of this list is 0, and it indeed printed 0. The second element of the list, which is index 1, is melon, and so it printed melon. The 6 is the -1 element. So Python has a really weird, or could be called convenient, it depends on your point of view, indexing structure. Meaning that you can go forward with positive numbers or you can go backwards with negative numbers. Negative numbers start at the end of the list. The very end of the list is the -1 index. The -2 index is the next to the last element, and so on and so forth, all the way up to the beginning, right? So you can index on negative or positive numbers. Either way can kind of be convenient. Without going so I can get against him. Okay, so that's how you index, and actually let me go here and print. See, so I've appended a couple of print PR. So I've appended a couple of elements, and at the very end here, as you know. Okay, so here are a few more examples, just printing out elements, and then there's a technique for lists. you might not want just one element out of a list. So very similar to MATLAB operations, you have something called subsetting, right? So where the index that you're trying to extract, you're allowed to have a range in that index, right? Okay, and so this is the C2:4. It's going to print indices. Really, I don't know. Is it going to print 2, 3, and 4? Or is it just going to print 2 and 4? Right? Those are little persnickety type of details, but the point to get across is that you can print multiple. You can extract multiple pieces of data out of a list just by specifying this range as the index. Okay. And finally here, the things that are kind of exotic within Python are the implied indices. So here I print C:3. So that means that you should interpret that as the very beginning of the list all the way up to the index that is specified by 3. Then I do something C:3:. Right? So it starts at index 3 and will go all the way or near the end. So I don't have to put explicitly those indexes there. Python knows what I'm talking about. So let's just try a few experiments with this. Okay, so yeah, so let's see if I can print out something else. Let me print out C, and so you'll actually have a point of reference for it. So let's see. Let's tackle this C of 2. So 0, 1, and 2. So it starts at 0.7. This is the 2 index, 3 index. Yeah, 2 index and 3 index. It doesn't actually print the 4 index. So it's the range is not necessarily inclusive. And the first time that you see that sort of stuff, it can get a little bit hairy. I don't ever remember this stuff time over time, so I make a little example just to know kind of what I'm doing. It's okay if you don't know everything about it. But there's always a Stack Overflow page near you, and you can do things just kind of interactively here to find out what the right answer is. So that's subsetting. Now, another class, or I guess container object, is called the tuple. It might seem at first blush to be very, very, very stupid, but there are applications where you want to either pass something into a function or you want to take something out of a function, and you don't really want that to be changed. You don't want your function to change it. You don't want anybody to change it. And a tuple is a really good structure for it. It's real simple, denoted by a paren, and then the different types of data there. This cell just simply prints that out. And I again use the extraction operator, defines a tuple, extracts the first element from there, prints it out. Boom. Now, again, in the spirit of experimentation, let's just try to see if we could do something illegal, right? I don't know if it's illegal or not, right? So what I'm trying to do is I'm trying to append to the tuple, right? Now, because tuples are immutable, is appending to anything altering it? Mm-hmm. Yeah, of course it is. But further, I don't know that the tuple shouldn't have an append operation on. But I'm just going to rush headlong and try to see if I can do it anyway. If I can catch the compiler or the interpreter slip. Okay, and lo and behold, I get a syntax error. It just very simply down there tells me that the tuple object, which is what we're using, has no attribute called append. Basically, there's no append method on tuple, and that's what you would expect. You wouldn't expect something that's immutable to be able to be changed.
Dr. How did you make it a tuple again?
So yeah, so that is defined with the parens. So this defines a tuple here.
So parentheses makes it a tuple.
Parentheses makes it a tuple. Right? So then assigns the variable d to a tuple of length 3. That's it. We can find out what the length of this tuple is too, just for grins. So it's a length 3 just as well. Well, what I'd like to know also in the sense of illegality is if I could, can I say assign, can I have a string, can I have a tuple of strings? Right. So how do you find out? Sure. Just go and just see. Right? Just go and see. Python is interactive. I'm not having to compile a million lines of code just to find out something. Let's see. So let's do. Let's assign another tuple. Experimental equal string 1. String 2. Comment these out because I know they're illegal. Yeah, it worked. Let's see if it worked. So I can have a tuple of strings. It doesn't have to. Okay. Don't want that really wrong. Okay. So dictionaries. Dictionaries are they're one of the most, I guess, important structures, data structures, in terms of their versatility, in terms of making your code more readable. Very much like lists, it's a heterogeneous structure. It can take most anything. Now, the key characteristics. So far, we have entries. List is defined with a bracket. A tuple is defined with a range, and a dictionary is defined with words. Right. So I define a dictionary here. Key is Melvin. The value is 77. The next entry in the dictionary key is Pamela. The entry is 64. Those represent our heights, respective heights and pitches. The next key is UT Tyler. Then I have not a numerical value, but I have a string value. I have another entry in the dictionary. Key being 3307 grades. The value is a list. The list contains strings A, D, and F. Right? The next key is a dictionary. It is the dictionary. The dictionary contains another dictionary that has a key of a string with value 7. I mean, it can just take anything. Right? Now, you address individual elements with, again, the extraction operator, which is brackets, and again, a key. And you can print out different things. And so we're going to go and do that. Okay. So the first one, I print my dictionary, Melvin, and that's 77. My dictionary, 3307 grades, A, D, and F. Print the length of the dictionary out 6. So this stuff is not really too bad. It just kind of builds, right? So you can define a dictionary, most anyway. Where it's most helpful in a machine learning context is reading, being able to read different types of data, particularly tabular data, where you will have your first row in a table may be, what the different columns represent. You might have a process, you might have velocities, heights, or whatever, where you want to delineate that with some type of a header. Well, this is a real good way to capture all of that data without really having to start. So now I say here that we should try to, a dictionary is not an immutable object. And once we have a dictionary, we should probably try to add some good stuff to it, right? For more information that we get, and maybe we should learn some more operation again to a dictionary. So here's where the experimentation. So I'm just going to insert a cell below. And I'm going to try to do some real cool stuff. So first of all, I don't know how to append to a dictionary, but I'm just going to go try something. And then after I fail, which I anticipate failing, I'm going to go to Google and figure out how to do it. Okay. So let's try this at first. And yeah, I don't think that this is going to work. Let's see. Okay, so that didn't work. So append is not what we should do. That failed abysmally. I'm still alive, and I'm going to go and find out the right way to do it. And if somebody has it here on Stack Overflow, they ask the same question that I did. Instead of going and looking up the documentation, they took the lazy way out and just asked a question because of the positive reinforcement they've gotten for that type of behavior. So let's see. Key value, empty dictionary. Oh, maybe update works, right? Okay, so let's try that.
Yeah, I'm just checking in.
Well, it seemed to have worked. At least it didn't give me an error. How would I verify that?
Print it again?
Yeah, print it again, right? So I need to see what I got. Or I can look at the link and see if it was increment about one. But let's do both of those. Right? So I could do it before and after. So I'm going to print that. I'm going to update it to print again. And then I'm just going to press the whole dictionary. Okay. Well, see, that didn't work, did it? Yeah, the length is changed. So that's no good. What? So that I'm not wanting to pop. Insert. Update. Yeah, that just clearly didn't work. What else? Okay. So that question is garbage. Uh-huh.
I do have the answer. I don't know if it's playing around or not.
We're kind of playing around with it. I'm trying to teach a resource. Okay, list, Dale, set, dictionary. Okay. Constructor. No, they don't tell anything there in the easy documentation.
Try the insert.
Insert?
All right.
Why not? That's a good attitude. Okay. Insert's not the one.
What about the plus equal operator?
Plus equal. Oh, right.
My dictionary equals my dictionary plus.
Plus equal. Okay. So I need to take these brands out, right? Plus equal. Plus equal. Okay. So no operation there. Well, John?
We don't even use the addition syntax. We use an index. It's just ready to receive new entries.
Right.
My dictionary bracket feeling now equals here. Your bracket.
Yeah, but then you would have to know what the length of the dictionary is. I just want to append something to the end.
No, the,
Oh, you just put that in there, right? Just
Yeah.
put that entry in there. Okay, right. Right, that's right. Okay, all right. So all of those were pretty big guesses, but ultimately, I think that should. Well, it still has link 7. It didn't insert it. Well, it did actually, but it looked like it took one off, right? Because it inserted it in here.
no, we were at 6 before, weren't we?
No, it's 7. Well, oh, you know what? I never reset that variable. Let's see. How can initial print the link of my dictionary, then I insert this, but then I print it again. So yeah, that's real. Yeah, I think that should work. Well, let's see. Let's do this. My dictionary. Then let's do this. Okay, so my dictionary 2. Even my dictionary, right? So we just compare the length of both of those. So this is this is the length of my dictionary, and then we're going to insert into my dictionary 2, filling now again and scared, and then print the length of that. And maybe there's a difference there. Okay, so we have 7 and 8. Right. That's a little bit of a jank. It's a little bit confusing, but I was overwriting that, and I didn't use other variables, and that obscured what I was actually doing. But the upshot here is to insert into a dictionary. You just put another key in. Okay. All right. Well, that was a little hairy, but dictionaries can be hairy. And I guess the broader point too, it's okay to look up records, unless you're in an exam type of situation. That's completely unacceptable. Stuff like that, but again, it's not that type of work. Okay, so control structures. Typical control structures that you would expect in any language, and that's why I just say that, languages are just syntax. Once you know what you want to do, it's just a matter of just finding out the right syntax to do that, and not really that deep. Oh, also, before I leave that one, let me just show you just how to. You might want to know what type of keys does my dictionary contain, and you would just print. Like my dictionary 2 keys. And here are the keys that the dictionary has. That could be kind of useful too. But again, this is just to kind of get the conversation started as to what, to kind of inspire you to look into other things. Okay. All right. So control structures, typical if then else, for loops, while loops, bada boom, bada bang, the whole 9 yards as far as control structure. No, most common ones, most everything you use. So if you have a programming language background or something like that, again, it's just a matter of find out syntactically how you do that in another language. Python is really easy. The only really kind of annoying thing with with Python, and this will wind up biting you pretty good sometimes, is you'll be going along and you will forget to put the colon, right? And the interpreter will bark at you for that and not let you proceed any further. And most subtly, you will forget to indentation. And you'll wind up, well, I guess Python is good now with this version. It will tell you there's an indentation error. But these type of little errors and stuff can wind up costing you, up to hours or something, when it's really not a problem with your logic. It's just a problem of syntax. Anyway, here, so print 6 equals 7. That's a Boolean, and the results of 6 equals 7 should be
Here.
the result of 6 equals 7. If it's a Boolean. Well, it should be definitely right? Under all number bases. Okay. So then I do another assignment. I assign G as 9.8. And what is so special about 9.8? Gravitational acceleration. If G is less than 10, we may be on Earth. If it's not, we're definitely not on Earth. Right? So that's just a simple if then else. Look at the colon, look at the logical comparison, the colon, the else, boom, we do it. Okay. Loops. Number of times that I want to loop in. 4, have my loop variable. The conditions on it, well, it's not a condition, it's the number of times that we go through that loop variable. Print I plus 1. That prints the numbers out 1 through 10. Let's go ahead and run this and see. Okay. This is all as is expected. Let's see. What else can I add to this to make it even cooler? Well, I can. You might not know what this range is, right? This little range operator. So let's just check it out. Range 10. And so if I suspect it just will print the numbers out 1 through 9. Yeah, or 0 to 1. So it does. Okay. Next section, using other people's code. Right. It makes, depending on your bent, makes life worth living, right? I suspect you have often used other folks' code in an illicit type of way. This is condoned. That's the big difference. And we build off of other people's stuff. I'm not a numerical analysis type of person, but it allows me to leverage those routines in numerical analysis. So somebody that does that and does that for a living and really likes that stuff and takes it home to work with, I want to leverage it. I don't want to keep that type of stuff. I don't want to write my own eigenvalue routine. That's somebody who loves that stuff. Let's see. So that's that's really the key to programming, leveraging those type of concepts. So the way to do it in Python, it's really kind of 2 key ways. Maybe there's more. I only use 2, but they both involve the import statement. So from most common, you'll see import NumPy as NP. What this does, it pulls down the whole NumPy namespace in a global variables that it might create I, for instance, E for another one. Does it have Boltzmann's constant in it? Are any of y'all got some MEs, y'all really like Boltzmann's constant. Yeah, might have that. There's Roche's constants for your chemistry people. I assume it has, I don't know that for sure. But anyway, it pulls down the whole namespace for you. And so then I just did another one here from scikit-learn.metrics, import accuracy score. Those in my machine learning class know that after you, and you will too, maybe in a few weeks or so, after you design a classifier, you really want to evaluate the efficacy of that classifier, so you can do things like this. All right. So that's import. One is import module, I mean, the namespace, how you're going to reference the namespace. So in subsequent programs, we're going to reference NumPy as only NP. So let me run that so I have it for subsequent cells. Okay, now, NumPy itself. NumPy, as I kind of alluded to, is an extremely important module. Once you import NumPy and probably its companion SciPy, you are endowed with all of the power of MATLAB at that point. So if you import NumPy and SciPy, you should be able to toss out MATLAB in the trash. MATLAB is okay. You have to use it kind of sometimes, you know, just as a tool. Somebody might have a lot of code that's written in MATLAB already. You definitely don't want to spend the time rewriting it yourself. So you leverage that. But if you could do without it, do without it. Is how many have the $99 edition of Student MATLAB?
Got the full one.
It's a lot more expensive once you're no longer a student. Once you're not a student, don't try to get the student edition. That's just trifling. So don't act like a student once you're not a student anymore. Okay, so let's go to the same thing. You kind of assign. Okay, so this is just a raw list, right? This doesn't have any numerical type of syntax and stuff like that. I'm just assigning lists. Okay. So then if I go and print A plus B, it simply concatenates the two lists together. That is not what I was wanting, right? Well, I was wanting to add each of the individual elements in the list. So that is a logical error. It's not a syntax error, but a logical error. Okay, not what we meant. So I go and I change those. I change those arrays, regular lists. I change them to NumPy, and then I more or less get what I wanted. That's more or less what I wanted. I wanted an array of numbers. The type of that, which you can see with the type statement, it is indeed a NumPy ND array. That can cost a lot of time too, making that very mistake versus okay. So here in this cell, I just do a little dot product. I dot those two vectors together. I create a little matrix here, a little 2 by 2. Little 2 by 2 matrix. I do a solve. MATLAB, that's A\B. Right. This is probably better to solve. And then there's a lot of numerical stuff under the hood, least squares, probably that type of stuff. But you don't really care at this point. You just want your A is. Probably QR decomposition. Print X. So, we got a little syntax here. Oh, no, same shape. Oh, it says it doesn't have a solve. Well, that's strange, isn't it?
Solve is in MATLAB.
So solve should be in NumPy too. Why doesn't that work? Doesn't that bother you?
I may be confusing things, but don't you have to clear your system bit like SY, SM, X or Y or whatever before you?
Oh, that's for symbolic, right? For in MATLAB, we're symbolic.
Yeah.
Well, we're just trying to solve the linear equation. Solve linear equations. NumPy. Oh, so I forgot. It's not in the NumPy. It's in the NumPy linear algebra module, right? So I forgot that len alg, right? And so it gave me a little nasty error. Okay. So let's see if this works. So, okay. Well, that still didn't work. I think the problem here is the shapes. So let me just take that off because I'm going to run out. Input operation mismatch as coordination 0. So 2 by, oh, wait, you know what? Because I'm trying to solve a 2 by 2 system but my vectors are 2 by 3, or three dimensions in that one. Right? So let me just take this off, and let me define this E. So B equal NP dot array -7. Okay. So 0. Yeah, right. So I prove here that you actually solved it by B minus AX, right? So if I solve that, I should wind up with 0, 0, and indeed I wind up with 0, 0. So that just quality checking. Okay. Yeah, I say note the way that we define the matrix. A matrix is an array of arrays. It can be a little bit funky when you first see it. Okay, so let me go. Okay, so now I just want to declare some random data and just check it out. And then I want to look at the complex number capabilities of NumPy. So are complex numbers important?
Yeah.
That's the right answer, especially amongst you numbers. So let's see. So it's 2 by 2, not a number. Yeah. Oh, so it didn't allow me to do the complex number. Wow, okay. Square root. That's pretty cool. No. That's. No, I don't really. It's doing. It wants to use the complex square root, but I really don't want to go. I don't really have time to do this, but I might leave that up. So finally, file IO. I have.
Just to give you time.
Okay, right. I'm trying to speed it. I didn't know if I would have enough material after this where I gave too much material. So,
you're gonna have to come back to talk to us more.
well, this just the beginning of the conversation. Right. So file IO, just define the file name, open the file name I'm opening as read, and I just do a little demo. Let me let you check the file out. That's what you do. Oh, I'm using my Jupyter. Let me just do this. Turn it on. Okay, so here's the text file. Some some sentences, numbers, or whatever. I want to open that up and I want to read it into Python. Okay, open it. Another variable equal f.read that reads the whole thing into the variable another bar. And so I just go and I print out what it is. Since the text file is really small, it should be print out the whole file. And then I just want to look at the type of it and see what that comes up with. And then I just want to go through, I want to go back, and that's the f.c0. I want to go and print out what each line is, and that's that. Just introduce a little bit of file IO. Run this. Seems to work, right? Let's print out all these values here. The type is just one great big string. And then I iterate through each line. That is with the for loop for line and line. I even give a nice little line number just to be kind to the user. Okay. So before I end here, let's see. So I wanted to show you a little bit of plotting. Yeah, I hope it worked. Right. Oh, I wanted to do show you a write function and stuff like that, but we're running out of time. I gotta get you. Okay, so Matplotlib is one of the best plotting utilities. It gives you, I should have said, with NumPy, SciPy, and Matplotlib, you have everything that you need in MATLAB because MATLAB has pretty good plotting capabilities. Matplotlib makes it, the syntax very similar to what you're accustomed to for MATLAB for plotting. And so here, I just plot a little simple sine wave. I go and I declare my linear space between negative 2 pi and 2 pi because I wanted 2 periods, right? Pi is 2 pi period, sine is 2 pi periodic. And then what do? I just want 50 points. I want to plot it and I want to show it. There it is. 2 periods of a sine wave. And you can dress it up and do nice things with it. In my classes, I always require labels, titles, legends where necessary, all that good stuff. But you can do that pretty easily here. Pretty much the way that you do it in MATLAB. Yes, sir.
Is there a way that you don't have to type in NP every time you use it?
No.
With the NumPy?
No. Well, I think you can import the whole. I think you can. Right. I think.
Like using namespace STD, it takes all the STD.
Yeah, I don't really know. I don't really know how to do that. I never do that. I don't think that's a good practice because you want to know what namespace you're pulling that function from. Particularly if there's one type of conflict, but there may be a way just to use that. I don't know for sure. Okay. So, and my plan was to kind of dress the plots up, like I said, with labels, titles, grid, spaces, all that good stuff. But we're running out of time out here rapidly here. And finally wrapping up, a session gives you a little taste of Python. More practice with tangible goals. Find a goal, something cool that you want to do in Python and try it. Don't think about it, try it. You will not, it doesn't happen by osmosis. Right? Find something that you want to do and go and do the research and stuff to make it happen. Put fingers to keyboard, produce some code. Don't just talk about it, right? Do it. Okay, so with that, try something small and build from that. Get comfortable with a Unix operating system. And machine learning, that's where it's happening. You're going to be severely limited in what you can do if you only do Windows. And that's for a variety of reasons that I don't have time to go into. Okay. So learn to use different tools. That's one of the first reasons. There's really good tools and stuff, and you need to learn how to use them together. Learn scripting, that's the other reason why I learned Unix. And particular text processing. Most of the data that you're going to be using is text data at first, particularly for engineers. Text processing is very important. So tools like regular expressions, Perl, alt, cut, sed, all of those are really important. Validate your data, validate the results that you're getting, use kind of scientific principles. Here, the next one, learn how to build open source software. So whether you like Windows or Unix or something like that, learning how to build that stuff is really how you're going to learn how to use your platform, right? If you don't know what a Makefile is or CMake or Visual Studio Solution stuff is, you really don't know your platform that well. And that's really important as to what you can accomplish, how well you know the platform that you're working with. Okay, so get involved. Engage in projects that rob you of your precious time. You know, it's kind of ironic. Oh, I don't have any time to do this. You don't have time not to do it, right? If you want to talk about something more interesting, when you go to an interview, other than I solved Maxwell's equations on a square, right? That's not that interesting. I mean, but if you did something interesting in AI, or you put something interesting in AI machine learning on your resume, that might get just enough interest for you to get an interview. Right? Purpose of a resume, one purpose only, is to get an interview. You must be an interesting person enough for me to bring you into an interview. 4.0 is not enough for me to bring you in. Right? Okay, all right. So with that, I'm going to adjourn. Maybe we have I'll let the moderators, defer to the moderators, Q&A. Any quick questions?
Questions for Dr. Robinson? Let's give Dr. Robinson a hand for just want to make a couple of quick announcements before you guys head out. So last week we had a couple of a group of people go and help out RV impacted homes, and last week they did drywall and continued to rebuild some of the houses and also did electrical inspections. If you feel like you want to try out and get some community hours, talk to Victoria, and she'll hook you up during the weekend.
Oh, hey, how do you,
So yeah, they've been helping out doing community service, rebuild our community. Upcoming events, we have a Valentine's Day bake sale. We're looking for volunteers, so we'll be sending out resources that we covered today, also some surveys for you to sign up if you want to help us out with that. There's going to be an NVIDIA Deep Learning webinar happening next Tuesday, February 13th, I believe, from 11 to 12 a.m. So we'll send you out the link as well for that. Texas Robotics Club meets Saturday, and Abraham is going to, if you want to join the carpool to go and check that out next Saturday? This Saturday, okay, at 1:30. Next week, Ron will be doing a lesson on the anatomy of Python, more continuation on Python, more familiar with the programming language. Okay, and then updates. If you guys are interested in joining a project, we have a couple of projects starting up. A beginner project, if you want to just get your feet wet, Victoria will be leading a well logging regression project. Go ahead and talk to her if y'all have any questions about that. We also have the drone case that Lynn created. That's going to be working on a drone case for a phone. So possibly if y'all are interested in that. Any other projects? Talk to Charles if y'all have any suggestions or anything. Another thing, if you consider yourself a advanced programmer, talk to Dr. Robinson and we'll get y'all hooked up with some of his projects. Another announcement, last one, would be Nestle's having a meeting following this meeting, so starting up in room A218, we'll be discussing a job fair. It's the last job fair of the semester, so you might want to get into that as well. Lastly, can we take a group picture over here? You can do for our meeting, and then you guys can go. Thank y'all for coming.